Hello, maurieo. Find the equation of the curve. Now this is a second similar curve in the series. So if you've been watching the previous video, you will know that this curve here is a parabola and it's negative. So I'll just get the words going here. Oh, there it is. We'll just back the truck up a little bit. We've got a little bit on there, and we'll just turn on our laser pointer here so we can point, which I've discovered since the last video I did. Bloody marvellous, isn't it? Hey, this technology. So this curve is a parabola, and as you can see, it's upside down, well, compared to the other one. It sheds water. If you put it out in the rain, it wouldn't catch any water. So we say that's negative. Our throat's getting a bit dry there. So, yeah, it's negative. And so when we look at the standard equation of the graph, it allows for both negative and positive. And this is it here, y equals a, x, capital A, x minus A, and x minus B, the two factors. But as you can see here with this particular one, it doesn't cut the x-axis twice. It just comes down and touches the x-axis at that one point. So this is a quite specific case, this one here, and what we say in this case is that it sort of touches it twice at the same point is one way of looking at it. It hits it once on the way down and once on the way up, and so we can sort of say that. But ideally, the best thing is to recognise this situation as a toucher, or it just comes and touches the axis. And so we've got to say that when x equals 0, when y equals 0, when y equals 0, as we can see there, x equals negative 2. And negative 2 minus a, we'll just work that equals 0, and a equals 2. Well, that's all well and good, but where do we go for our second root, if you like? But no, that's not what we do. We know the graph is negative, and we can say then that y equals negative a, and here we go, x plus 2, x plus 2. So we put it in twice, okay, x plus 2, x plus 2. And then just working a little bit with that, work it, we get y equals negative a, x plus 2 all squared. All right, so that's that case there, x plus 2 all squared. And yeah, that's our graph. Now we've got the a there. We need to work out what that is, and as I said in the last one, that's a sort of a scaling effect. Our standard parabola graph, or the simplest one, is y equals x squared, and then the remainder of the things just translate or scale, reflect that graph around the Cartesian plane. So if the a makes it the scale is at y equals 2x squared, y equals a half x squared is the a, and that's what we're trying to determine, is the scale or size of our parabola. So to do that, we go to when x equals 0. Now these are when y equals 0 and x equals 0, they're like tools. They're in your toolbox, and you can always drag them out for any graph or equation, and they tell you what's happening on the x or the y axis. So when x equals 0, which is the equation of the y-axis. X equals 0 everywhere on the equation, on the y-axis, so it's a straight line, x equals 0. Y equals negative 4, so we've got that there, and similarly on the x-axis. So they're tools in your toolbox, and you can bring them out for anything. They're sort of the go-to tool, really, for a mathematician, and that sort of thing. So we get y equals negative 4. Okay, so let's put that information into the graph, and we get y is negative 4 equals, and we've got negative a, which we're trying to find out, and x is 0, so 0 plus 2 is 2, and that's all squared. And then, all right, negative 4 equals a negative 4a, divides through by negative 4, and we get a equals 1. Now, it wouldn't matter if we had y equals a x plus 2 all squared. We didn't sort of recognize that it was a negative graph, and well, all that would happen is that a would be negative 1, so the negative comes about naturally anyway, so you don't need to worry too much about that. But because I recognised that it was the negative 1, I sort of factored that into the equation, and yeah, the actual scale of the thing is the a, you know. So I've got it at 1. But if you had omitted the negative there and just had y equals ax plus 2 squared, you'd get a equals negative 1. But you'd still end up in the same place. You'd still end up with the equation of the graph as y equals negative x plus 2 all squared. And that's what that graph is. So, yeah, that's it. I think, I'm pretty sure that's the end of my, yeah, it is. So I'll just go back the truck up. So there you go. The equation of that curve is y equals negative x plus 2 all squared. Bloody marvellous.